Hello Internet, if you've got a couple minutes, I'd like to introduce you to the metaCube, which is this 3D printed cube that I have modeled from scratch in JavaScript and printed on my Ender 5 Pro. So this video is going to be about 3D modeling and 3D printing. So as I said, this here is the metaCube. In its smallest size, it's exactly 1 centimeter by 1 centimeter by 1 centimeter, and has a rectangular hole punched through it on all sides such that you can see through the entire cube. What's interesting about this design is that I've designed the code to scale very easily, so you can print metacubes in multiple dimensions. So I have here the second largest metacube, which is 2.5 centimeters by 2.5 centimeters by 2.5 centimeters, with a 1 by 1 by 1 cube embedded into the center of the 2.5 by 2.5 by 2.5. So you can see on all 6 sides here, this same rectangular pattern is punched through the entire cube. And if we want, we can even go up slightly larger to this cube, which is 6.25 centimeters by 6.25 by 6.25, with a 2.5 by 2.5 by a 2.5 and a 1 by 1 by 1 cube embedded into the middle. So as I spin this around on all 6 sides, you can see that there's this same rectangular pattern punched through all 6 sides, creating this recursive pattern of theoretically infinite dimensional metacubes.
So how does it all work? Well, the first step of the design process is to create a virtual representation of the object that you want in code. So as I mentioned, this cube was designed in JavaScript, and you can see on the screen here all of the code that was used to create this cube. I won't go into detail about how every single thing works, but you can pay attention to a couple of variables that are set up at the top here, such as size, which is at 10, cutout size at 5, and size multiplier at 2.5. So you can adjust some of these variables if you want to create different styled metacubes, but the main thing to look at is this generator function here, which takes one argument called dimensions, which I currently have set to 1, so that if I pop over into my web browser and refresh the page, you can see a one-dimensional representation of that metacube that I showed you earlier. And if I pop over back into the code and change dimensions to 2, refresh the page, you can see a 2-dimensional cube. And similarly, 3 creates a 3-dimensional cube. So this is all done in JavaScript with the help of a JavaScript library called 3.js, as well as a couple other smaller libraries. Like I said, it's theoretically infinite, so I could change this dimensions to 5 or something like that. I haven't printed this, but there you go. I can at least create a virtual representation of what a 5-dimensional metacube would look like if I wanted to print one. So that's the first step of the process, is learning how to work with, there's various different programs out there. I like to do it directly in JavaScript myself, because then I have like atomic level precision over every single vertex in my mesh. But there are other alternative design options if you don't want to go directly into code. Yeah, that's the first step, is creating a virtual object that can then be exported to an Stl file. So in the world of 3D printing, there are 2 main file types that you really need to know about. Stl files, as just mentioned, as well as Gcode files. If you're sharing designs or models with people over the internet, what you generally tend to do is you share the Stl file. And the website that people use to do that is this website here called Thingiverse. So I have uploaded all of the Stl files for my metacube to Thingiverse, and you can see them here. I've also uploaded them to GitHub, although as far as 3D printing is concerned, Thingiverse is a little bit more of the main hub. Links are in the video description, so if you'd like, you can link over to Thingiverse and download the Stl files for my metaCube. Once you have the Stl file for a 3D object that you want to print, the next thing you need to do is that you need to slice that Stl file into a Gcode file. So STL, which stands for Standard Triangle Language, is different from Gcode, which stands for Geometry Code files, in that Gcodes will be specific to the printer, the filament, and the print settings that you're using, whereas the Stl file simply contains the raw geometry of the object. So I'm using a software program called Cura, which slices Stl files into Gcode files. I have already inputted my printer, my filament, and my print settings. So I'm not going to go into detail about that here, but that's in general the difference between Stl and Gcode files. So Cura offers quite a different number of features for exactly how you want to slice your Stl files. The main thing you probably want to look at is the layered view over here. So as I slide this ball up and down, you can see exactly layer by layer how your 3D printer is going to go about creating this object. I can change the angle maybe and look at it from the top if we want to see a bird's eye view, and slide the ball back up, and you can see layer by layer exactly how your printer is going to create this object. So I think that's a pretty nifty view, and if there are any issues with your objects, such as parts that are too small, or parts that are floating in the middle of the air, or parts that have too much overhang, Cura should flag those issues here before you take it to your printer, so that's really useful. There are a couple other settings you can see, such as layer height, which is set to 1/10 of a millimeter, and that's my minimum precision, as well as infill, which is set to 30%. And you can play around with these settings depending on exactly what object you're trying to print, but that's a pretty standard setup I have here. Once you're happy with the view and your Gcode settings, you can export this file to a Gcode and take it to your 3D printer.
So once you have the Gcode for the file that you want to print, you can transfer it over onto your 3D printer via an SD card. So this is the 3D printer that I was showing you previously. It's the Ender 5 Pro. It's a fairly good printer for somebody that's a beginner into 3D printing. It prints in PLA as well as ABS, which is two different types of plastic. In the 3D printing universe, there's quite a wide range of 3D printers. Some print in plastic, some print in metal, some eject filament out through a nozzle, while others use lasers to melt powder. So there's quite a variety of printers, but yeah, if you're new, probably all you want is plastic printing, and for the price and the size, Ender is probably one of the best options. It's got a heated bed and a heated nozzle, and can print to a precision of up to 1/10 of a millimeter. And so far I have been more than satisfied with the quality of the prints that I've been getting. This is the metaCube that we've been looking at. I printed it here on my Ender 5, and I am very happy with the results that I've been getting. And if you have maybe 2 more minutes, I can show you some of the other stuff that I've been printing on my Ender 5, if you're interested in 3D printing in general. So 3D printing is a very exciting and potentially very disruptive hack on global manufacturing and global supply chains, as opposed to conventional manufacturing, where you have one machine that does one thing. We now have one machine that does everything. So that same Ender 5 Pro that I was showing you just a matter of seconds ago, that printed my metaCube, also printed all of the objects you see here on this table at a fraction of the cost that it would cost you to buy them at a hardware store. One of the first things I printed was this Carpenter speed square here. I printed that because I wanted to test the accuracy of my printer.
So I went out to the store and I bought a conventionally manufactured square to compare it to my 3D printed square, and they're essentially a perfect match. So there are no real concerns as far as accuracy is concerned. Whatever is in the Stl file generally comes out with 100% accuracy as a real world object. You can see 3D printed nuts and bolts here. So I can very easily thread my 3D printed nut onto my 3D printed bolt, and it threads very beautifully. All of these components came out at a fraction of a penny each. One of my most sophisticated prints, a 3D printed wrench that is fully functional and adjustable. So I can use my 3D printed wrench to fasten and unfasten my 3D printed nut from my 3D printed bolt. And there you have it. You can see the miracle in action, that components that would once be manufactured on the other side of the world and shipped to me to buy at a hardware store, I can now print at a fraction of the cost in my basement. As well, I have a set of Allen keys over here. They're not maybe as strong as they could be. I only used a 40% infill. Maybe I should have used 100% infill. I'm still kind of prototyping at this point. Also, if you had a metal printer, you could print these in metal rather than in plastic. But without making any changes to the Stl file, you now have a full set of Allen keys. The designs were downloaded online for free, and the material cost was about $1.10. I also have a 3D printed clamp here, which is again fully functional. You can slide the base up and down the spine, and then use the handle to fasten or to tighten the clamp onto whatever it is you're clamping, my finger in this case. So there you have it, again for about $1.25. So all of these hardware components are fully functional and could be done without any changes in metal as well. And last but not least, I did one thing that was less business related and more artistic. I printed this 3D mask here for fun, just because I thought it looked cool. But there you have it. Yeah. If you have any other questions about 3D printing or 3D modeling, put them in the comments below. But this is a very exciting time, a very exciting revolution. So until next time, happy printing.